Good morning and welcome back to microprocessor course. In today's class, we are going to learn about another important topic. We're going to start memory system. Memory system. We will talk about what is a memory, what are the different levels of memory storage, different types of memory, then physical organization of memory. So these are the main topics for today's class. Before we start today's class, I also want to check on the attendance to see if everybody is present in today's class. Class 5, number 1, 2, number 3, 4, 5, 6, number 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 22, Andy, 23, 24, 25, 26, 27, 28, 29, 30. Class 6, number 1, number 2, number 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, 22, 22. Class 6, 22, 23, 24, 26, 27, 28, 29, 30, P21, 6, 15. Okay, good. Now, if you still remember in chapter 1, we talked about evolution of computers, evolution of microprocessors, especially we talked about evolution of interprocessors. We went through different classes of computers. We talked about computer performance metrics. We talked about million instructions per second. We talked about CPU time and other evaluation performance metrics in the computer system. So these are the main topics we talked in chapter number 1. In chapter number 2, we talked about a specific microprocessor, 8086 microprocessor. We went through its architecture. We talked about addressing mode and instruction set. Instruction set. Addressing mode, instruction set, architecture. We talked about BIU, bus interface unit and execution unit. Now, in chapter number 3, we're going to talk about memory system. Why we're going to learn about the memory system? Now, we know that computer has many tasks to do, and each instruction relies on data. So we need a memory system, we need a storage. Well, the computer can store data and instruction. So that's why it is very important to learn about a memory system in this class. So we're going to talk about different levels of memory. We're going to talk about different types of memory and physical memory organization. Now, a memory is what? A memory is a computer component which is there to store data and instruction. If you still remember, we won't only learn about different levels of memory or types of memory. We wanted to talk about its physical organization and also understand about memory access time because it is very important in the computer system. Now, we have different levels of memory that we're going to learn in this class. But before that, I want to show you this picture that is familiar to you. We have the CPU. This is the digital computer component conceptual view. But now you see in the previous classes, we had this CPU. This component was the one which was highlighted because we were talking about this important component of the computer. Now, we have moved a little bit to talk about memory storage. That's why now in this class we have the memory storage, which is highlighted, which means we're going to talk more about the memory, not the CPU. We're going to talk more about the memory. Then we have the next component, which input-output devices. After the memory storage, we talk about these other important component of the computer. So we have the bus system, data bus, which is there to transit data, and we have the address bus, which is there to transit the address, the memory locations. And we have the control bus, which is also important to transit the status and the control, which allows the computer to manage the different operations being performed by the computer. Now, we have different bits in data weight. We have different bits in data weight, and we have bits in address bus as well. And we have also bits in control bus. Now, the number of bits in data bus and the number of bits in address bus, they are well known. But the number of bits in data in the control bus, they can be varied. They can be varied depending on what kind of operation being done by the computer. But the number of bits in data weight are well known and can help to calculate the number of words in the memory, or the number of bytes per word, or the number of bytes in memory, or the number of bits in memory. Now, imagine we have total number of bits in address bus equals to 9, and the number of bits data bus we have 32. Now, imagine we have number of bits here, we have 32, and the number of bits in address bus, we have 9. So we can calculate the number of words in memory number of words in memory. In memory, which is given by this expression 2 to the power of n, when n is the number of bits in address bar. So we can found, let's call this is n. So this is 2 to the power of n, that is 2 to the power of 9. So this is the number of words in memory. It is given by this expression 2 to the power of n, when n is the number of bits in address bar. We can also calculate byte per word. If you still remember how many bit is a word, number of byte per word equals to what? Now, this is like is number of bytes on data bus. We have number of bits on data bus. So this is also called number of bytes on data bus. So a byte is how many bits? Huh? A byte is how many bits? 80 bits, yes. Now, we have to calculate the number of bytes per word. Number of, which is also called number of bytes on data bus. We have the number of bits in data bus. That means we have this number of bits divided by 8. Okay? Because we wanted to find the number of bytes on data bus, we take the number of bits in address data bus divided by 8, right? Clear? Because 1 byte is 8 bits. So we have 32 divided by 8. Then we have 4 bytes on data bus. Clear? Because we have the total number of bits in data bus is 32. Now, the total number of bytes on data bus, we take the number of bits in data bus divided by 8. Then we have got 4. Now, we can also calculate the number of bytes in the whole memory. How many words? How many words are in the memory? We have found 2 to the power of 9 words in the memory. Now, we wanted to find how many bytes in the memory. Each word is 4 bytes. Now, we want to find the total number of bytes in the whole memory. When we have the total number of words in the memory and the total number of bytes. Now, we wanted to find the total number of bytes in the memory. We have the total number of words in the memory, and we have the total number of bytes per word. Now, if you try to understand this, we wanted to find number of bytes in memory is what? We have total number of words, and each word is how many bytes? Is 4 bytes. Okay? Now, what is the total number of bytes in memory? Now, if you try to see, let's say we have 2 to the power of 9 is, how much is it? Huh? 2 to the power of 9. Huh? 256. 2 to the power of 9 is Huh? 512, right? Use your calculator and tell me if it's correct or not. Correct or not? Correct? Yes or no? Huh? Yes or no? 2 to the power of 9 is correct? Okay, now let's say we have the whole memory. Memory, we have one word 1, word 2, till 512 words, okay? Right? These are words, number of words in the memory. Each word is how many bytes? Each word is 4. Now, 1, 2, 3, 4. We have 1, 2, 3, 4. We have 4 bytes per word. Now, how many words, total words in the memory? It's not clear? We have 4 bytes per word, and we have 512 words in the memory. We wanted to find the total number of bytes in this memory. So this is the whole memory, okay? This is the whole memory system. Memory system, memory. Our memory is 512 words, and each word is 4 bytes. We wanted to find the total number of bytes in the whole memory. You take the total number of words, 512, right? Times 4. Then how much is it? 48. Now, we have a total number of 2048 bytes in our whole memory. Okay? Clear? Now, if I want you found the total number of bits in the memory, what is the total number of bits in the memory? Huh? We have found the total number of bytes in the memory. What is the total number of bits in the memory? Class 5, number 15. No? Present? Absent? Huh? What is the total number of bits in the memory? Now we want to find the total number of bits in the memory. In the memory is what? We have the total number of bytes in the memory. Each byte is how much? How many bits? Huh? 8. So what is the total number of bits in the memory? But you understand the logic. Huh? We have the total number of bytes. That means we have 2048 bytes. So we need to find the total number of bits. We take total number of bits total number of bits, D, number of bits in the memory is 248 times what? 8. Then it's, tell me, what is the total number of bits in the memory? 16384. So 16,340. 84 bits in the memory. So you see, with the total number of bits in data weight or on data bus and the total number of address bus, we can calculate the number of words in the memory, the number of bytes per word, the number of bytes in the memory, and the number of bits in the memory. Questions? Questions? No? No questions? Now I have number of bits in address bus, which is 10. I have number of bits in data bus, which is 16. I want to find the number of words in memory, the number of bytes per word, and the number of bytes in memory, and the number of bits in memory. You have 3 minutes. Okay? Done? So you have to solve this problem. We have the total number of bits in data address bus is 10 bits, and we have the total number of bits in data bus. We have 16. Then I want you found the number of weight in memory, the number of bytes per word, and the number of bytes in memory. The last one is the number of bits in memory. You have 3 minutes. Please solve this problem, everybody. Did you get my question? Everybody, you need to solve this problem. We wanted to find the total number of weight in memory, the total number of bytes per word, and the total number of bytes in memory, the total number of bits in memory when we have the number of bits in data bus and the number of bits in address bus. Then tell me. Take your notebook. Try to be fast. Please try to be fast. Did you get my question? Finish? Can I collect the papers? make sure you are solving this problem. Double check this one. Double check this one. Not correct. Okay, what is the total number of words in memory? Class 5, number 15. What is the total number of words in memory? Two to the power of 10, right? Then tell me, what is the answer? 1024, right? Okay, class 6, number 30. 30. What is the total number of bytes per word? Class 6, number 30. 2, because we have 16 bits in data bus, we want to find the number of bytes on data bus. That is 16 divided by 8. We have 2. Class 6, number 8. What is the total number of bytes in memory? Class 6, number 8. Absent? Okay, plus 1, number 9. Class 6, number 9. Class 6, number 7. Absent? 7, 8, 9. Absent? Huh? Class 6, 7, 8, 9. Absent? Huh? Absent? Huh? Okay, class 5, number 9. The number of bytes in memory. We have got the number of words in memory and the number of bytes on data bus. We want to find the total number of bytes in memory. Yes, you are correct. Because we have the total number of words and each word is 2 bytes. So the total number of bytes in memory, we take the total number of words times the total number of bytes per word, that is 1024 times 2, that is 2048. Now the total number of bits in memory is the total number of bits in memory. We have found the total number of bytes. What is difficult? Huh? Eight times? Yes. Good. So, this is quite easy. You see that with the number of bits in data weight and the number of bits in address bus, it is quite easy to find different specifications, more details about the memory system. Now, we have memory terms. We're going to talk about random access memory, static RAM, DRAM, ROM, PROM, EPROM, flash, volatile, and non-volatile memory. We're going to also talk about main memory, registers, and we're going to talk about cache memory, content addressable memory, or dual inline memory model. So we have first to talk about magnetic core memory, which was introduced between 1951 and 1953. But it was remained the dominant form of the computer memory for about 20 years. So it had to store information using what we call tiny magnetic toroid. We call them also links. As it is depicted by this picture, we see that each link can be magnetized in one or two directions. If it is in clockwise direction, that means we have the logic 1, or if it is in counterclockwise, that means we have the logic 0. It is also arranged in XY plane. So it used 3 or 4 different Ys. So this is the type of the memory which was remained dominant in the years of 1950s. Now, you may think about, since we have a computer system, what is the memory size? What is the memory size of a good computer system? I wanted to buy a computer. What is the memory size of a computer system that can help me to store my old data? Now, there is a continuous growth when it comes to computer memory size. The memory size is increasing. So how much is enough? That is the big question. How much is enough for our computer system? How much size is enough? So in 1981, 60K ought to be enough for everybody. So this 60K limit as memory size wasn't like a design mistake or something that gets declared, but it was a practical engineering choice back in 1981. But as the software evolved, it quickly became a painful constraint, which means that as the software evolved, there is a need of higher memory size. As the software evolves, as there is more advancement in software, we need a higher memory size to accommodate the software, the new software. So how much memory size is enough? This is a big question, because it has to evolve with the development of the technology. To accommodate all the software that we need to have enough memory size. So this was not something that Bill Gates declared back in 1981, but it was a practical engineering memory size, which was ought to be enough for everybody back in 1981. But if you try to see today, this memory size is very, very small, because we have been observing a high development in software. So we have also to increase, to think about how we can have a higher memory size to accommodate all software that the users need. So memory size is a big question in computer system. Now, memory levels. Memory levels. We have a processor, if you still remember. Now, inside the processor, we have a very specific memory. What is the name of the memory that is incorporated in the processor? What is the memory? A small memory, but a very fast memory, which is incorporated in the processor. We have registers. Registers are really small memory, which are integrated in our central processing unit. They are really small, but they are really fast. Now, after register memory, we also have another level of memory, cache memory. Depending on the technology, we have different levels of cache memory. Maybe we have level 1, level 2, level 3, and so on and so forth, depending on the technology. So they are made of static RAM. We're going to talk about what is a static RAM. And after the cache memory, we have another level of memory, which is the main memory. It's made of, it is a type of DRAM memory. This is there to hold more our active data and instruction. Then after the main memory, we have second storage memory to store data permanently. We may have also a tertiary storage depending on technology for backup purpose. Now, registers, they are small and very fast memory, which are integrated in our central processing unit. The use of registers is to hold data and instructions that are currently processed by the central processing unit. So all data and instruction that are being processed by our CPU are stored in registers. Now, the second level of memory is the cache memory. Is near our central processing unit. It is there to store frequently used data to reduce RAM access. So this will allow our computer to speed up the processing because all recently or frequently used data and instructions are stored in near memory, which we call cache memory, to avoid frequent access to the main memory, which is the random access memory. Now, there is the next level of memory, which is the main memory, RAM in other words. This is there to store active program and data. Active program and data. Now, this memory that we just talked about, they are what we call volatile memory. What does it mean, volatile memory? Volatile memory only holds data when the power is on. Volatile memory. They are volatile memory. That means they need to store the data when there is a power. If the power is off, that means they will lose everything. They will lose the data that you have stored there. So we have the second storage memory. This is a disk. It can be HDD or SSD. So this is there to store our data permanently. They are no volatile memory. So if you try to see this alone, as the size of the memory increase, the speed decreases. Clear? Memory size increase, speed decreases. memory size increase, then memory speed has to decrease. So which means as the size of the memory increase, the speed of the memory will decrease. That's why our register memory, they are little small in size, but they are little fast. Cache memory, they are bigger than the register, which means they are slower than register, but they are faster than main memory. You understand? Huh? So as the size of the memory increases, the speed decreases. Okay? Small memory, like register memory, is very fast. Main memory, bigger memory, very slower if you compare to the register memory, or if you compare the RAM to different levels of cache. So size increase, speed decreases, and also the cost decrease. Sorry? Easy to make. Good. So which means that if you want to buy a memory, you need to take into consideration which kind of memory you want, for which use. You wanted to store your data permanently, you need a big size memory. So this is memory level picture. Give us a big view about the different levels of memory, how fast they are, and what size they are. Okay? Now, make sure you do understand these memory levels. You have to understand about the relation between the increase in size and the decrease in speed, and also the cost that involve when the speed is higher or when the size is higher. So this is very important. So we have registers which are there to store data and instruction that are being processed by our central processing unit. That's why they are integrated to our processor. Then we have the second level of memory, which is a cache memory. Is a type of static RAM, which is there to store most frequently data and instruction to avoid more frequent access to the random access memory, to minimize the waiting time, because the main memory, the DRAM, is slower than the cache memory. We wanted to store all frequently data and instructions in our cache memory. Then we have the main memory, DRAM, a type of memory, DRAM, which is there to store active data and instruction. We have then the second storage memory to store our data permanently. Now, let's talk about a little about registers, register file. We have register, which is a group of master-slave flip-flops, and it can be addressed or multi-port. So this means for addressed, it is in a system with multiple registers, and each one needs to be uniquely selected to read from, to read, or to write to. To read from or to write to. So it has to be done via an address decoder, and also it can be a multi-port, which means we have multiple reads or multiple writes at the same time. Each port has its own address line, data lines, as well as a control logic. So this is your 5-minute break. Take your break. We're going to resume class after break time.